Hello students, welcome to Sarsa classes. Now in this particular lecture, we're going to discuss the Parikh during oxidation. So what is the reaction basically over here? Again 1 or 2 degree alcohol, alkene BH, alkyl, aryl, alkenyl, alkynyl and solvent. Most of the times it is going to be acetonitrile, triethylamine. The oxidizing reagent is pyridine SO3 in presence of DMSO. So we are activating again DMSO over here using the SO3, and that leads to the formation of the aldehyde or ketone depending whether it is primary or secondary alcohol. So mechanism, as you can see, DMSO is there. This is the resonance structure of DMSO, and that can make a nucleophilic attack on SO3. That is how it is getting activated. The alcohol will make a nucleophilic attack on the S plus unit of the sulfur. So this cleaves away as sulfate, and this is the intermediate that we are forming over here, and that is being counterbalanced by this particular pyridinium sulfate ion. In the next part, what we can see is that in the presence of a base, this particular hydrogen will be abstracted. Okay, how it is abstracted? Here a CH3 molecule will be losing the proton, forming a ylide. So this is your ylide. Why it is called ylide? S plus and it is CH2 minus. So now intramolecular abstraction of the hydrogen taking place, and that leads to the formation of the ketone. Let's look at some practice problems. So this is going to get oxidized to form the aldehyde. Rather, it is forming the alpha beta unsaturated aldehyde because this is the allylic alcohol. Here it is forming again from allylic alcohol to alpha beta unsaturated aldehyde. Here we are seeing that it is forming the from alcohol to ketone, from here alcohol to again ketone. Here the primary alcohol is getting converted to aldehyde. Few more practice problems. We have been given a 3 degree and there is a primary, so obviously the primary will be undergoing oxidation. Here we are having again a primary alcohol that will be undergoing oxidation from the aldehyde. In the next reaction we are discussing Fritz-Moffat reaction or simply Moffat reaction. What is Moffat reaction? We'll be using 1 or 2 degree alcohol, and that will be getting converted to ketone or aldehyde in presence of something like a DCC. Okay, so over here acid that can be used is pyridinium hydrochloric acid or pyridinium with TFA, trifluoroacetic acid, or dichloroacetic acid or phosphorus acid can be used over here. So as I said, this R3N double bond C double bond N R3 is basically a dicyclohexyl carbodiamide, which is known as also DCC. Now how is the reaction happening? DCC is taken and it is going to be activating the DMSO. So DMSO will attack over here, leading to the formation of this intermediate. Now this intermediate again S plus is being generated, so it will be activating the alcohol now, and again via a cyclic intermediate one can see that this will lead to the generation of the alkoxysulfonium ylide, and dialkylurea will be the side product. Now this particular intermediate, which is the ylide, will undergo intramolecular hydrogen abstraction, and that leads to the formation of this ether, which is the DMS, thioether basically, and we are forming the oxidized product over here. Let's look at some practice problems again. Oxidation of primary to aldehyde, primary to aldehyde, primary to aldehyde. Here we have a tertiary, so this will not be touched. Primary is there, so it will convert to aldehyde, and so on. Next topic that we will cover is open-hour oxidation.